Hey there everybody and welcome back to another Blender tutorial. It's me, your favorite Blender tutorial boy, or I think I'm gonna change the title from now on, favorite Blender tutorial man. And either way, I'm back here again today to show you how to do this text wavy effect, and before I get into it, I just want to say there's a bit of a precursor, a bit of a story to this one, and I feel like I should share it so that people don't get angry and say that I plagiarized or throw rocks through my window. I don't know what you guys are capable of, but this result that I'm going to show you how to do, which by the way, fully procedural, right? You can change the text to be like, what's something fun, what's something kooky, creative, bottle. I see a bottle on my thing, and boom, it says bottle. We can control the number of iterations of that. We can also control like the waviness, all this. Bit of a story with this one. This was inspired by, first of all, a Reddit post that I saw on the Blender subreddit. I'm like, oh, this is cool. I look through the comments. Apparently, this guy was inspired by another guy. I'm like, okay, we're going deeper down the maze. Speaking of mazes, originally was made by celestialmaze, it seems, unless he copied it from another dude. I don't know how far this goes, but this result is what we're going to be creating, and I think something interesting about this is if you look at the technique this person used, if you look into it, what this guy or girl or whatever, I don't know who Celestial, what this maze has done is basically done a bunch of stuff using curves and stuff like this. I'm going to be showing you how to do this result using a different technique, kind of the obvious one, extrusion. But because this person has their thing up on Patreon, I'm not going to put this one up on my Patreon because it's not my original idea. So with that precursor that I'm sure you just do not care about, it's like going to history class when you don't like want to. They just kind of put you there, right? I mean, if you want to be in a history class, it's great. But when they're like 3 years of American history and you just want to be taking math classes, you know. Either way, let me show you how to do this. It's super simple. By the way, just because I say it's simple doesn't mean that it's necessarily easy for you. So I'm going to handhold you throughout this whole process. I know geometry notes can be intimidating. I'm going to talk through every step, and it's going to be, you're going to understand it by the end. So to start off, open up Blender. I'm using 3.2. You can use an older version, doesn't matter. Go to geometry nodes, make a geonodes group. So this cube has a modifier. This modifier is described by these nodes. And the question is, what nodes do we need to put in what order to get the results? Well, first of all, I'm sure we don't need the cube, so I'm just going to delete the group input with X so that there's nothing going to the output, right? We're not seeing anything in the 3D viewport. What do I want to see? Well, I want to see some text doing some stuff. But before we get to the doing some stuff, we need text. Not a cube, but text. So how do we do that? Well, as I was making this, I'm like, okay, we need a text thing. And I was typing that in, and it just gave me a bunch of textures, right? Turns out the way you use this navigation is when you mean text, the official word is string, like you're programming. So you have a string, that's basically a piece of data that says, here's something I typed out. We have string, join strings, whatever. I'm going to be using a node called curve to strings, or string to curve. I guess it's the other way around. What this does is we put in a string, so it could be A, B, C, C, D, and it's going to take that and convert it into an object we see, namely a curve. Okay? To get a bit more control over this, we can take the string and just create a string input. I guess not a slice string, but just a raw string input. And what this is going to let us do is outsource this to its own node. So here we have bottle, or I think what I did for mine, what I know I did for mine was CG matter. You could put any piece of text you want in here. It's going to convert it into a curve. Fine. Next order of business is, yes, it's a curve, but if I was to render this, kind of go to the render view and disable overlays, you don't see anything. Why? There is a curve there, but it doesn't have any thickness to it, so the data exists, but there's no faces or geometry for us to see, right? So how are we going to see it? So let's turn this curve into a mesh. So we took a string, made it a curve, and now let's make it a mesh. How do we do that? Fill curve. You want to take the curve and fill it in with geometry. That's why we use it. And you can see it just fills it in with geometry. Now it's renderable, right? And what we're going to do later down the line, not yet, but we're going to extrude it, and that gives it thickness. So we're kind of going step by step by step. One thing I want to say here is that the string to curve node has a lot of inputs, outputs, stuff that is useful. And let's go through a couple of these. So first of all, how do I want my text to look? Should it be big text? Should the characters be spaced out? We have control over all of this. Mainly, I just want to pick a different font, and that just goes to your main font library. So you can play around with this. The way we're going to build the rest of this is so that it doesn't matter what we do here. So you can do whatever you want, and it's going to keep working down the chain. So we have a string. It could be anything. It turns into a curve. We fill it in. And now the next order of business is we don't just want one of these. We want a grid of them, kind of like side by side by side, which we then extrude and wave and all this. So how do we make a grid or kind of an array, a bunch of copies of this? Well, one kind of silly approach is maybe use the array modifier. And by the way, that's not going to work unless you, this is where it gets a bit in the weeds, but if you look at the data for what we have in this last step, I use the viewer, you can see all of this is basically an instance. In fact, it's 8 of them for, the 8 letters here. What that means is, yes, we turned it into geometry, but it doesn't actually have any data that we can manipulate in the array node. So what you'd need is you need to realize instances. You can see now it takes that instance and makes it a bunch of vertices, just a bunch of data. Don't worry if you don't understand this, but kind of the key insight is this will make the array modifier work. But that's kind of silly because if you do it in the array modifier, then we have to add another geometry nodes thing. It'd be easier if we do it all in one geonodes group and kind of remake the array modifier. How do I want to do that? Well, first of all, keep this realize instances. It's going to be useful for us in a bit. But to create a bunch of copies, I want to instance or copy it in a bunch of places. So I'm going to instance on points. If you haven't seen this node, don't worry. What it does is it takes a input mesh or series of points, and it says for each of those points, make a copy of our text object, make an instance of it. So for example, if I use a primitive like a mesh line, so you could see it right here. Here's our mesh line. It's just a line going vertically. I can make it have less points, and it gets shorter and shorter and shorter. I could have it skew to the side, whatever. What I want to say is for each point on this line, instance our geometry. Here's what that looks like. So again, you can see our line is a bunch of points going vertically on the z-axis. And for each of those, especially if we create more points, it's going to get one of our instances, even if we change what that says, right? This is kind of what we want, but we want them to be copied not vertically on the z-axis, but kind of horizontally on the x-axis. So what I'm going to do is I'm going to reposition my line. And if you look at the mesh line, you can see what's happening is I'm just stretching it out. Basically, I'm saying it's composed of 9 points, and for each point, shift the next one by 1.5 meters on the x direction is what's happening here. But you can see has a bunch of points and it's copying them. The issue is I need to find the exact right number so that they're not overlapping, right? So something like that. And you're like, okay, fine, we do that. Now we do it for the y-axis. No, because what happens if I shorten this to CG mat? Well, now we need to change this number. And the key insight here is that the length of this text or the size of basically this object is going to determine our gap here. So how do we figure it out with math and not have to kind of customize it every time? Well, what I want to do is I want to make a function that tells us exactly what this x should be. So let's take this offset and turn it into a combine xyz. So in the same way that I outsource the string to a node, I'm going to outsource our offset vector to a combine xyz, which combines an x, y, and z. And I want the function relative to the x. Now here is how we do it. So let's think about what we want. We want to have an object being this filled in text, and I want to know exactly how long it is. That is going to change if it has more letters. Now it's going to go for a bit longer. So I want the function that tells us its kind of bounding box. What is its x length of that, right? So if I was to make a box that tells us kind of how big is this thing, how big is that on the x-axis? Well, here's how we do that. Here's a cool little trick. And there might be another fancier way to do this, but I think this one's very intuitive. Attribute statistic. What does it mean? It means we can feed in an attribute, some kind of data, and we can get information out of it. Well, what data do I want to feed into it? I want to feed in its position data, right? I want to feed in x location data. So we can then take the maximum value, in other words, this one, the biggest x value, and subtract by the smallest x value, kind of like finding the range. Well, how do I get position data? Well, there's a position field, right? This just gives us positions of every single vertex. And by the way, this is why realizing instances is important, because before we just had a bunch of instances, and now we get a bunch of geometry data. If you don't understand this, it's not the biggest deal, but it is important to have our attribute statistic work. So I want to feed this into my attribute statistic. In other words, what I'm saying is, hey, Blender, this mesh, right? So we had the curve. let me go back a bit. We had the curve, then we filled it, then we realized it, and I'm saying, hey, take this and tell me information about its position attribute. Specifically, position attribute is a vector. It has an x, y, and z component, so I'm just going to turn it into a vector. And now we can get a bunch of information out of this. Now, those of you who are observant might be like, oh, why didn't you separate x, y, z and said only look at x data and then do stuff with it? It's because we're going to need to do it again with y, so keeping it as a vector lets us do it all at once. So what do we want? Well, we have our position data basically all loaded in here, and I want to say use that somehow to tell me its x range. Which, by the way, I guess we don't need to subtract because I think we have a range node, so I guess let's just try that. What I did before, because I guess I didn't notice that, is I took my maximum, subtracted it by my minimum, which gives us the maximum x value, and also y and z, and subtracts the minimum x. So we have the max. This is impossible to type. And we subtract the min, and that will give us this range. Okay, that's the idea. But I guess we have a range thing. So what I want to do is now I want to separate by x, y, z, so I can take the range and say, hey, give us maximum minus minimum only for the x. We connect that here, and now let's see what that gives us. Perfect. So you can see it's exactly ending right where the spacing is exactly correct, right? So if I was to add a letter, you could see they're still not overlapping. Add another, they're still not overlapping. In fact, it's giving us a perfect fit, right? It's giving us the rightmost vertex and the leftmost vertex. They're basically overlapping, right? If you want to add a bit of a buffer, so we have the function that gives us the exact correct number. If you want to add a bit of a buffer, we could just add a tiny little quantity. So like 0.1. So it's going to calculate the correct spacing and then add a bit of buffer. So if we had apple, it works. If we had just the letter Q, it works. It does not matter. It does not matter. And we do have a bit more control over this, right? So the mesh line tells us how many points. This is basically the array modifier now. Okay? All we've done is made a function that tells us exactly what spacing to use. Well, we have that. If we want to now do it again on the y-axis, so now we're copying in this direction, so we have a grid, what do? Literally the exact same thing. So I'm going to instance on points, so we're just going to reuse our setup on a mesh line, so it's going to do some weird stuff right now. By the way, I think I inverted these. I want the mesh line to be the points and instance, the instances. We're basically going to do the same thing. The only difference is now the offset vector is not going to be a function of x, but it's going to be a function of y. So I'm going to connect the y into here. Again, notice I'm doing literally the exact same thing. I'm going to even add my buffer. And you can see it's copied it. So basically, we had one unit that was copied over the x-axis, and then we took that whole thing, the line, right? So this whole output, and then we copied it here. So it's like, first we're copying a piece of text, and then we're copying a line that already has copies. Again, you can control the spacing, and the spacing, the count, everything, and the spacing can be independent for x and y. And let's just do one final test. Perfect. All caps. Perfect. And I should also mention, again, anything we do here, we change the font, it's going to work, okay? I'm going to pick a thick font for this. Okay, so now we have a grid of, procedural objects. By the way, we should save. Again, I'm not going to make this available on Patreon, so not available on Patreon because celestialmaze made it, but I think it's valuable to find this approach and have somebody actually explain it in a video. Okay, next thing I want to do is we could add the wave. Maybe we should add the wave. But we also need to give this thickness. Again, we know the way we're going to give this thickness is with a extrude mesh that we already talked about, and I just want to make sure that's working. Yep. I thought maybe we'd need to realize instances again, but it seems like it doesn't matter. I think what's actually, maybe we do need to realize instances, and we'll get into that in a moment. But either way, we need a wave is the next order of operations. How do we get this thing to now go up and down with some kind of wave pattern? Well, if we're doing that, we need to kind of reset the position of these vertices, right? All of this is basically composed of a bunch of vertex data. And I want some of those to go up and down like they're bobbing up and down on a wave, okay? In other words, I want to reset the position. So we're going to use a set position node. Again, if you haven't seen this before, I know this because I've used geometry nodes a lot, and you will too. after you use it a lot. But set position is going to let us set the position. What do I want to do? I want to set the position up and down, like with the wave. So offset, just like last time, we're going to outsource this to a vector. I want to do it up and down on the z-axis. So here's up and down and up and down, right? So I'm moving every single vertex in this case up and down, or we could do it to the left and right. I want to do that, not the same everywhere, but off of some kind of function or some kind of noise or something that makes it look like waves. In fact, we do have a noise texture node, which gives us noise data. So let's just connect that to the Z, and you can see we're getting some variation. If I was to increase this, you can almost see it almost looks like each line. It's a little hard to see, but each line has its own height instead of each vertex having its own height. This is an indication that we, again, need to realize instances. Because, again, if we go to instance on points, the thing we're feeding into set position, we expect to see, yes, it's 9 instances corresponding to our 9 lines, right? So it's getting a bit weird what the instances are. Either way, anytime we want to manipulate the actual data of each vertex, you need to turn it into geometry, so realize instances. And you can see now we can actually control each vertex, and it looks like a mess, right? So this noise texture, which is basically the wave function that we're moving up and down on the z-axis again, up, down, but now we connect it. I want it to be less aggressive. The ways to do that is you bring down the scale, and you can almost imagine this as the size of the waves. So the smaller this number is, kind of the lower the frequency is, big waves. If you go like this, it's like high frequency choppy waves. So you want to do that. You want to bring down the detail so they're nice smooth waves, and you can almost see that looks nice. You can play with some distortion, whatever. But I'm just going to find numbers that I feel like look good for what I'm doing. So it seems like a scale very close to 0 at a low detail, whatever. Now, if you want to animate these waves, you could either take that noise and bring it into the 4th dimension, which gives you this W slider, and you can see it animates. Don't worry about that. What I recommend is we're going to use the coordinate system for this noise texture. So basically needs a way to say which vertex gets which value of noise. Well, we need to assign some kind of coordinate system. It by default uses position, which is why nothing changes when I connect it. If we take the position and then we offset it to the side, it's almost like we're taking the coordinate system that it's using to tell us how up and down the wave is going, and we're shifting it to the side as if the wave is going along the x-axis. So you could either add keyframes, or if you're using a newer build of Blender, we have the scene time node, which lets us, again, I want to outsource this vector because I want to connect a individual component only to the x. The scene time node lets you connect the seconds, basically telling us what time we are in the animation. And it's going to offset on the x. So you can see as the frame number goes up, it's animating. And in fact, all of this can be modified, right? So we can take this and multiply it by like 10, which means go 10 times faster or 3 times faster. And I think something like 2 times faster looks pretty good. Again, all of this stacks in the sense that we can add more, less, whatever. Okay? So now the final step is we want to extrude it. Now, what we could have done is we could have extruded it and then done the wave function, but then I think it would have done some weird stuff to our geometry. Because this just lets us have this, and then we give it thickness. If we did it the other way around, the thickness creates new vertices that move independently of the others. So order of operations matters here. Either way, we take this. We're now going to finally extrude the mesh, which is going to do something weird, and I'll explain it in a second. You could see it's kind of like... I mean, it's almost like separating these faces. If it's doing this, disable individual. That's kind of the main thing. What individual does is it takes each face and extrudes it individually based on its own surface normal. So this is one way to do it. And I actually like the way this looks. But if you don't want this kind of... If we look at it from the top view, you can almost see there's this contraction and stuff. Like it's not extruding perfectly up. And I actually like the look of this. But if you want to get a different look... which I don't recommend. I think this looks cool. But if you want to get a different look, what we could do is for the offset, which is telling us in which direction to extrude in. Right now what it's doing is it's taking the surface normal. And the reason that it's doing this thing is because now it's waving. So sometimes the normal is facing this way and that way. Let me just actually show you. So because we have the wave, it's not like every extrusion is going to go perfectly up, right? Some of them are kind of off to the side, right? So because of that, we have that going on. But we can fix that, if you wanted to fix that, by including a vector that tells us exactly where to extrude. So I connect this to the offset. You want it to go up on the Z. And now you can see it's kind of very boring and plain. So I think this is kind of the way to go. Another thing that I was just thinking of that we can do to add detail is it's very grid-like right now because that's how we generated it. But what if we did it kind of like bricks where each line has a bit of an offset or every other line, right? And I'm thinking, how do we do that? Well, we have a function that tells us how to instance the rows the second time, right? It's dependent on X. What if, or on Y, if we increase X, it does do a bit of a shifting. It does, but we want only every other one to be shifted. So maybe what we can try, this is getting a bit into weeds, now we're going advanced. If we take the index, and this might not work. It might not work. But if we take the index and we say, let's do a function depending on its like modulo. So I'm just going to try something. If it doesn't work, then we're going to try something else. But if we take modulo 2, which is telling us go from 0 to 1, 0 to 1. No, it does not like that, long story short. Okay, so let's try a different method. So we have the row generated, then we instance it upward. What we could try is let's try translating the instances. So now we have 9 copies, which, by the way, we're going to realize at the end here. But we have 9 copies. Again, if we look at our viewer, or I guess we have 11 because we have 11 rows. You can see there's 11 instances, and each one should have an index between 0 and 11. So what I'm going to try here is let's take the index. That's going to give us this number, 0, 1, 2, 3, 4, 5. And I want to say for every even one, so let's say 0, and then it goes 1, 2, 3, 4, 5, 6. For every even number, let's try translating the instance. So let's see if that works. So I'm going to again try the same thing. If not, if it doesn't work, we'll cut. But I'm thinking this should work. So we take it modulo 2. What this means is it basically you divide the number by 2 and take the remainder. What that ends up meaning is that if you take 0 and divide it by 2, you get 0. That's even. If you take 1 and divide it by 2, and then you take the remainder. Does this make sense? I feel like it makes sense. It should give us every other one, alternating 0 to 1, but we'll see if it does. So I want to take this as the selection and then translate on the X, and yeah, that works. So what have I done here? Translating on the X moves all our instances on the X, but if we make a selection that says, again, basically what I'm saying, what I'm claiming here, and this is a bit higher math than some of the other stuff, what I'm claiming here is this isolates the even numbers because it divides by... Does it divide? It takes the remainder if you were able to divide by 2 in some sense. So it's like if, for example, I take a 3, so 0, 1, 2, 3. I feel like I'm explaining this badly, so I'm just not gonna. What this does is it alternates 0, 1, 0, 1, 0, 1. I don't know why I can't explain it right now, but my brain's just not allowing me. I just hit the gym. That's my excuse. All my brain power went to my muscles, you know. But now we realize the instances. We do the set position, which gives us the wave. But now we have the offset. We extrude mesh, and it has that kind of clenching effect, that kind of compression and stretching. And I think that looks a lot better now that we have the offset and we can control the size of that. And actually what you can do is if you want it to get really fancy, is if you want it to be exactly half a unit translated, so like half the length of a CG matter or whatever text. Again, we have this range, which tells us exactly that. So if we take this, let's try that. We take the range of the X. Again, that's saying if we only had a single piece of text, right? How long is it on the X-axis? I divide it by 2. Right? So take it, divide it by 2, and if I connect that to the X here, so now, and I guess we need to, again, I always say outsource, we need to combine X, Y, Z, so it's only on the X component, and then we connect this here, and then we view it. Yeah, that will give us exactly a half unit, which I think looks pretty cool. Okay, I know we got into weeds here, but what's the point? The point is we can change the text to anything, and it will follow this rule. Again, remember we made some custom nodes for us, like the buffer here, which I think looks pretty cool when you do it like that, and the buffer here. And yeah, I think that's the essence of it. I mean, the rest of it is you just kind of render it nicely. By the way, maybe one issue to talk about is when you fill in the curve from the very beginning, this triangle versus n-gon thing happens to matter. So when we do n-gon, you could see it's kind of giving us a more rigid effect, and there's a reason for that. Basically, the reason is when you triangulate, it's going to add a bit of extra geometry, which means more points to manipulate. Actually, let's just view it. So you could see triangles create this whole mess, whereas n-gons are nice and clean. So what you want is up to you. Different looks. And I think the reason Celestial Maze didn't use extrusion is because of something related to this. He didn't want, or she, or I don't know. They wanted, what did they want? They wanted no shading artifacts, which again, a bit more in the weeds, but I think we can ignore that for now. I think the point is we know how to do this. We built it up from kind of beginner basics to something that's actually a nice complicated result, and then you just render this. And I think one more thing I just want to mention super quickly is you don't just have to animate this on the X, right? You could have it be the waves on the Y, so now you can see it's going this way, or why not just do a combination of them? I'm going to do something like linearly independent, or like a linear combination, I mean, where like there's a strength of 2 on the X and 1 on the Y. So it's almost like instead of the wind blowing exactly on the X or exactly on the Y, it's going to be some kind of combination kind of in this direction. And you could actually make a function that changes the direction of the wind as time progresses, but whatever. I think I'm happy with this. You take it, you render it, it looks good. And I'm sure I went for way longer than I could have. How long? Half an hour almost. Either way, let's wrap it up here. So hopefully you enjoyed. Hopefully you learned something, and a nice little beginner's geometry nodes tutorial to whet your appetite. At this point, I always like to pimp out my Patreon, and there are 3 reasons that maybe you should join beyond just supporting this channel and the CG Matter channel, the 2 best Blender channels on YouTube. When you join the Patreon, you get 3 things. You get early access to tutorials. You can see tutorials early before other people. It's available for free, but you could still see it earlier, sometimes days, sometimes a day earlier. That's there. Another one is blend files. For this one, again, I'm not uploading it based on the principle, but at this point, I've been doing Patreon for like 3 years, so there are hundreds of blends and project files and everything that you can just go and download right now. So that is still hyper relevant. The projects I worked on yesterday, 2 days ago, they're all there. And thirdly, exclusive tutorials. Right now, I'm working on a backrooms tutorial, and I wanted to do something extra with that. Oh yeah, I wanted to talk about compositing in depth. There are exclusive tutorials. I've uploaded a few at this point that, again, you can go and watch. Those tend to be more in the weeds, more complicated, if that's your kind of thing. Either way, hopefully you enjoyed, and I'm sure you learned something. So thank you for watching, and I'll see you on the next one.